So, another sensor that you may be interested to just complete the discussion on this indeed is the oxygen sensor. Oxygen sensor, actually it is mounted in the exhaust manifold, it is mounted there, and it will tell you how much of unburned oxygen, it will tell you that. Okay. So, this is important, right. You want to monitor the oxygen levels to understand all about gauging the fuel mixture. So, you can say O2 is an output again, like throttle pressure sensor. So, there are other sensors, there is something called MAF sensor, mass air flow, which measures the amount of air flow that is going into the engine manifold, that is also there is a MAF sensor. Then you have, as I said, oxygen sensor, there is temperature sensor, then there is a speed sensor, there is an RPM sensor and so on. All of these sensors I can show you in terms of an engine ECU. Okay. Here is an engine ECU, here is an engine ECU. Okay. I drove this discussion only to tell you that this is what we want to do. We want to put this simulator in action. Each one of these knobs you see 5 knobs here. These 5 knobs correspond to different sensors as part of the engine ECU, and these are essentially temperature, then there is temperature, then there is RPM is here, then you have speed which is here, then you have oxygen here, and then you have the mass airflow coming here. So, all of these are important parameters if you want to understand the engine, its functionality, if you want to look at how to use these sensors in a manner that you can build autonomous systems, you have to understand the functions of each one of them. We will come to that. But before we go on, I must tell you, you see this ECU here, this is a complete ECU system, right. You also see that there is a connector here, this is called the OBD2, OBD. What OBD stands for is onboard diagnostics version 2, it is called OBD2, OBD2. So, from 1996 onwards, any vehicle that is manufactured, particularly cars, there was a need for putting this onboard diagnostics connector, which will give you data from all the ECUs which are there inside the vehicle. Now, what are those ECUs? How many of these ECUs exist? Well, a modern vehicle can have anywhere between 70 to 90 ECUs, okay, and this is a very important thing, alright. So, which are carrying up to 2500 signals, okay, they are carrying 2500 signals. You can regard what is a signal. To give you a feel of what a signal is, you can imagine that this is a signal, right. You are giving a signal by a wire, you are giving another signal like this, you are getting an input signal back to the ECM, these are all signals. So, you can imagine the number of signals that are there in a modern car. The number of signals can be as high as 2500 signals which are exchanged between 70 to 90 ECUs, so many signals and all that. So, you can imagine data that is exchanged between point to point links, if you want to do between one ECU and another ECU, ECU 1 and ECU 2, if you do it this way, this is a point to point link. Okay. This is ECU 1, ECU 2, you can have up to n ECUs as I said, and each one establishing a point to point link like this. This is ECU, ECU 3, and ECU 3 in turn establishing a connection to ECU 1 on a point to point link. So if this is being established, this is not there, right, and if this is there, this is perhaps not there, because they are all doing point to point. If you want to do this, if there are n ECUs, okay, the order of communication channels will be the order of, simple calculation, communication channels will be n square, right. So this is, and if n starts growing, you will not be able to cope with the increasing ECUs, because you will have several issues of weight, you will have weight cost, then you will have problems of complexity, and you will also have problem of mainly reliability. You can't do it this way, you can't go on having point to point links, and because reliability will get compromised, which essentially means that you will have to look at multiplexed communication over a shared medium, that is data multiplexed. Data is multiplexed over a shared medium. So you have a shared medium, you have ECU 1, you have ECU 2, you have ECU 3, and so on. This is a shared medium. So you go away from point to point to a shared medium. Okay. So that is a very important thing, and once you have a shared medium, you will need a protocol, a set of rules which are to be exchanged, set of messages that are to be exchanged, and rules for managing the communication, right. All of this will be required. Access to the bus, access to the channel, no access to the channel, and so on and so forth will all have to be looked at. All of this means if you move away from this point to point connection to this kind of shared medium, you see the reduction in, what? Specifically the weight, reduction in weight due to what? The wiring harness. Okay. There is a mention that BMW's weight reduction, when it moved away from point to point to this kind of shared medium protocol based system, it reduced the weight by 15 kgs, which is whopping, right. So all of this means, what is that famous protocol which will allow you to choose on a shared medium? Well, that leads you to CAN. What else can it be? What else can it be? It is indeed CAN, and CAN was introduced by Bosch. Okay. And once people started looking at CAN, which stands for Controller Area Network, wiring simplicity came in. There was a very good possibility that all of this is leading to autonomous driving again, because you are not isolating ECUs anymore. They are all talking to each other, they are all on the same shared medium. You are not talking of islands of ECUs, because you could not manage to connect them together. You just made them into islands, and those islands were just able to do amongst themselves which could never have moved towards autonomous driving, it could not have. So, this shared medium allows you, all the ECUs are now on one shared bus kind of, and then that bus indeed is the CAN bus, it is moving towards autonomous driving, that allows you to do several things. Before we move on to further parts of this module, it is good to sort of understand the OBD2 protocol and the variants of them quite well. One of the first things that you will see when you read up on OBD2 is SAE J1850, there is an extension called PWM, okay. This gives you a data rate of 41.5 kilobits per second, standardized by Ford. Then there is another variant called SAE J1850 VPW, okay, this is variable pulse width or something. PWM means pulse width modulation, and VPW simply stands for variable pulse width. It gives you lower data rate, something like 10.4 kilobit per second, and this is standardized by General Motors, okay. These are all giants who have generated their own standards. Then there is an ISO standard, ISO 9141-2 is another standard, and this is asynchronous serial data rate of 10.4 again, and it is somewhat similar to, I would say, very similar to RS232, okay. So, there is this ISO 14230 KWP 2000, I will just write it in bracket. Then there is a very famous ISO standard, and that I think you should recall, you should keep in mind, and that is ISO 15765, 15765, okay. And this is what I just discussed, is the CAN, okay. It gives you 250 kilobit per second, and it can also give you high speed CAN, which can go up to 500 kbits per second, right, and this is most popular. So, there are some voltage levels that the CAN specifies, what should pin 6 be, what is pin 14, and what is CAN H signal, what is its voltage level, what is the minimum and the maximum, all that is specified part of the ISO 15765. Therefore, it is important to know this, and this, as I mentioned to you, was standardized. The CAN protocol itself came out by was designed by Bosch. So, now let us see, before you understand anything with respect to the different ECUs, you will have to look at the following parameters or following I would say metrics to understand what should be the ECU's responsibility specific to a given part in the vehicle. One of the things is response time, the other is jitter, bandwidth, and redundant communication channel. See, all this is coming now slowly into our domain, because we have now decided to go in with a protocol, isn't it. So, if you come to a protocol, you have to look at what does the protocol, that will tell you from any communication networks book that these are important parameters moment you go in for a protocol. So, again all this is leading to very interesting things happening in the automotive world. Essentially the CAN protocol has to give you certain responses, should be within certain jitter for different functions of the vehicle. So, what are these functions and how do we divide them? So, typically you will want to divide a vehicle. Let me draw a picture of a vehicle, it is my famous picture which I keep drawing, and this is a wheel. So, you can divide the system into three parts where there is an engine compartment, then there is the place where people sit, and this is, I would say, cabin area or passenger area, and then there is this chassis area, right, on which this complete engine is mounted also on the chassis. Then the seats and other things are also laid out on top of them inside to build a cabin around the chassis. So, you can see that response time, jitter, bandwidth, redundant communication channels, all this that any protocol will have to provide will largely depend on where and what ECU you are referring to. Are you referring to an ECU of the engine compartment, engine related, cabin related and chassis related. So, you can divide them into broadly several functional domains. So, I will now put down the functional domains. Now, what these functional domains are, why do you need them? Because you have different features for them and you have different constraints. Now, if you look at real time control and safety, okay, you will be talking about the vehicle's powertrain. You will be talking about the vehicle's powertrain, nothing but engine control and transmission related, okay, real time control and safety, right. Next will be the chassis, which I showed you here. Next will be the chassis. When you say chassis, you are talking about suspensions, you are talking about steering, you are talking about braking, right. All of this will become another domain. The third one will be body or cabin, body area or passenger area, body which implements comforts. Comfort for whom? Comfort for passengers. Okay. So, all what you currently have can be part of this body. For example, music in the vehicle, then Bluetooth connectivity from your phone. Some people have these wireless Bluetooth devices, that is another functionality, right. And if you open the door, there is a light in the dark when you want to get off, you need some light on where you are likely to put your foot. So, there is a door lamp, right, and then there is a ceiling lamp. All these are part of body, comfort for passengers. Then you have power windows, right, power windows, all of that, then lamps, LED lighting, music, entertainment, all of that, and then of course the boot space switch, that is you press the switch, the boot opens up so that you can pull out your luggage and all that. So, that function, all of that is part of body. So, it is not at all important if something fails here, but these two you cannot afford, right. I would still put real time control and safety, powertrain is absolutely critical, followed by of course braking, steering and suspension, which are equally critical, also important, also very important. This can go in black, really it is not at all, nothing is going to happen, right. So, why this is in big red is because this is the one that will perhaps command this part, right. So, the big red will command the smaller red. So, if this fails, this cannot by itself know what to do, right. So, if engine somehow the command should come from this part to the chassis part, so that braking is there or steering is there. So, it should not fail here at all. Most of what we do in the autonomous driving space, different algorithms and all that perhaps will come here, which will then link to all these parts, steering, braking and all that. So, indeed everything is centered around this, the big one. Okay. So, these are the 3 domains you can say, and each one of these systems like powertrain, chassis or body have different response times from the network, jitter requirements, bandwidth, and whether you need a redundant communication channel or not will have to be considered in the case of the first two.